It's time to learn about piecewise-defined functions. First, let's review what the domain of a function is. It's the set of all values at which the function is defined. Now, we usually define functions using formulas, and we define the function wherever that formula allows. So, for example, the domain of x squared is the set of all real numbers, and the domain of 1 over x is the set of all real numbers except for 0, since 1 over 0 is undefined. But that's not the whole story of domains, because we can always restrict a domain more than the natural restrictions of a formula require. For example, take 1 over x. If we want, we can restrict this function to the positive real numbers. You might wonder why we'd ever want to do that. Well, one of the reasons is the subject of this video. Suppose we want a function that looks like what we see here, only with a line like this on the left side. We can express this function as a formula like this. F of x equals x plus 2 if x is less than or equal to 0, and 1 over x if x is greater than 0. Each of these pieces involves a formula that can define a function on larger domains than the ones used to define f. We've already talked about the domain of 1 over x, and x plus 2 can define a function on all real numbers. Restricting it to the real numbers less than or equal to 0 allows us to combine it with 1 over x, when we restrict that formula to the positive numbers. We're not using the parts of the graphs of each formula that spill over into the other formula's territory. Now let's go in the other direction. Suppose we're given this function, and we need to graph it. To do this, we graph each formula the way we normally would, but we only draw it on the part of the x-axis satisfying the corresponding condition. So we start by graphing 1 minus x plus 3 squared from negative infinity to negative 2. And I'll include the gray part just to indicate the piece of the graph that we'd normally draw, but don't want in this case. Next, graph x from negative 2 to 1. And finally, graph the square root of x minus 1 from 1 to infinity. Note the discontinuities, and be careful about where you put the open and closed circles. This one is closed because the corresponding inequality is less than or equal to, not strictly less than. That means that when x equals negative 2, we use the formula from the top line to determine the value of f. This circle, on the other hand, is open because its corresponding inequality is strict. Finally, note that f isn't defined at x equals 1. That's okay. Nothing says that a function must be defined everywhere. We could include a value at 1 if we wanted to.